Here's an example where we can examine the wage gap between men and women. So we have two random independent samples that yield the following results. We have a sample of 100 men and of 100 women. Subscript M stands for men and W stands for women. From the sample, we have an average hourly earnings of $36 for men and $32 for women. We have a standard deviation for men of 12 and a standard deviation for women of 10. And here are the 4 questions we want to answer, and we'll answer these in turn. Find the 95% confidence interval for the population mean for men and also for women. Find the 95% confidence for the difference in mean. Get the p-value to test whether the mean of men is greater than the mean of women. And are the sample means statistically different from each other at the 95% level? So let's go ahead and do this step by step. So let's start with question 1. Here we want to ask, or here we want to create a 95% confidence interval for the men and then next for women. So from this, we can look at x bar minus mu over the square root of sigma squared over n is distributed normally with a 0, 1. And this is if our population comes from a normal distribution. All right, but one thing that's here is, well, we don't have our sigma squared. What we have instead of sigma squared is we have the sample variance s squared. Well, that tells us that this is distributed normally with t n minus 1 degrees of freedom, except for when n gets sufficiently large, usually above 30. Then in that case, if we have a large enough sample size, the t distribution converges to a standard normal distribution. And so that's what we're going to use in this case here, because n is large. And so we can use the central limit theorem to say that t will converge to a normal distribution. So let's go ahead and set up what we have. So we have x bar for men plus or minus our z-score of alpha over 2 times the square root of sm squared over nm. And this is going to be our confidence interval. So we have to look up what the z alpha over 2 is. So let's look at our table over here. So if we want a 95% confidence interval, then we want our percentage to be 0.25, which is located right here. So our z is going to be 1.96. So that's going to be our z-score. So let's come back to our problem here. Now we can plug and chug. So we looked up this in the table. This is 1.96. So this is equal to x bar 36 plus or minus 1.96 square root of 12 squared over 100. And that 12 is our standard deviation for men. And so this is going to equal this range of 33.65 and 38.35. So we are 95% sure that the population mean mu is somewhere between this range for men. We could do the same thing for women. X bar for women plus or minus 1.96 square root s for women squared over n women. And this is equal to, we have 32 plus or minus 1.96 square root of 10 squared over 40. Again, 40 is our observation number, so it's greater than 30, so we can use the central limit theorem to say this converges to a standard normal. Otherwise, this t-stat would be different. And this is going to be within the range of 28.90 and 35.10. So we are 95% sure that the population mean for women is within this interval. So that's what we've done for question number 1. Now let's look at question number 2. Number 2 is asking to create a confidence interval of 95% for where do we think the difference in mean is going to be? Well, in this case, we can use the notion here that x bar 1 minus x bar 2 minus mu 1 minus mu 2 divided by the square root of s1 squared over n1 plus s2 squared over n2. If these are independent, then we get this, and this notion is they're distributed as a normal 0, 1. So this is the equation we're going to use to create the 95% confidence interval for this next question part, where we're looking at the difference. So we still have the same z-score, and so in this case, we will get x bar m minus x bar women plus or minus 1.96 times the square root of sm squared over nm plus sw squared over nw. And this is going to be our bounds for our confidence interval. So our confidence interval of 95% is equal to this. Well, let's plug and chug the numbers. So here we get 36 minus 32 plus or minus 1.96 square root of 12 squared over 100 plus 10 squared over 40. And this is equal to the range of 0.11 and 7.89. So the difference in wages for men and women, we are 95% sure that men make an average of 11 cents to 7.89 cents more than women, or that the population mean, mu men minus mu women, we're 95% sure that difference is between those bounds there. So that's question 2. Now let's look at question 3. Get the p-value for the test that that the population mean of men minus women is greater than 0. So let's come over here. So our null hypothesis is that mu men minus mu women is equal to 0. And our alternative hypothesis is that men minus women is greater than 0, meaning that on average, men make more than women. So we can set this up using something very similar to we did the confidence interval, using the same notion of the distribution of x bar minus mu, or rather of x bar men minus x bar women minus mu men, mu women. It's men squared over n men plus s women squared over n women, that this will be distributed normally 0, 1. So we're basing it off of that statistic as well. So in this case, we're going to get 36 minus 32 minus our null hypothesis is that mu men minus mu women is 0. So that's where we get that 0 from, divided by the square root of 12 squared over 100 plus 10 squared over 40. And if you calculate this, this is equal to 2.02. So this is our z value. So if we're to think of this graphically, there's our normal distribution, is we've calculated a z value 2.02, and we want to calculate the area to the right. So let's go to our table. Let's look up 2.02 And there we find the value of 0.0217. So from this z-score or z-value of 2.02, the area to the right is 0.0217. We call that the p-value. So the p-value equals 0.0217. Now we can go ahead and go to number 4. And number 4 is, are the sample means statistically different from each other at the 95% level? So this is slightly different than what we just asked. So in this case, our null hypothesis is that mu men is equal to mu women, and alternative is that they are not equal, because it's asking, are they different? Not is one greater or equal to the other. So this can then be rewritten as men minus mu women equals 0. And this is men minus mu women not equal to 0. And so we're going to conduct the same test, right? And so it's going to be the same thing, x bar men minus x bar women minus 0. That's from our null hypothesis, divided by s men squared n men plus s women squared n women. And so this is where we get our 2.02. Again, this is our z value. But in this case, we're looking for a 95% confidence interval. So we want to find a critical value in our table such that 95% of our data is here, meaning that 0.025 is here and 0.025 is here. And so I'm looking at the table now for 0.025 to identify what the critical value is. So here's our table. We're going to look up for 0.025, and that is located right here. So that critical value is 1.96. So if I come back to my pick graph here, this critical value is 1.96 and negative 1.96. And so now there's two things that I can do. I can look at this z value and put that into our distribution. In this case, it is located in our rejection region, meaning that the z value is greater than our critical value, therefore we reject. The other thing to note is that our probability is 0.025, and based off this z value, we get a p-value that was 0.0217. So we'll also reject if the p-value is less than alpha over 2 on a two-tailed test. So in this case, we would reject the null and conclude. So the null hypothesis is that they're the same. So we would reject that and conclude that we have evidence to suggest that men and women have different wages, or that there is a wage gap between men and women.